Welcome to solverfy.
We're asked to find the crossing number of the Peterson graph. Now, we have, by the last example in this section, that the Peterson's graph is not planar. So it follows that Peterson's graph has a crossing number that must be greater than or equal to 1. Now, suppose you remove an edge from the graph. The graph will not become planar because the graph will still contain a subgraph homeomorphic to K33. So, for example, if the edge that was removed was not between a vertex of the set FDJ and a vertex of the set EIH, then by the same reasoning in the textbook, we have that the graph still contains a subgraph homeomorphic to K33, and otherwise we can just rename one of the other vertices so that again we can use the statement in the example. So this means that the crossing number graph is non-planar still, and so the new graph has a crossing number greater than or equal to 1, and so it follows that Peterson graph has a crossing number greater than or equal to 2, since we're adding back an edge. And now, let's move the vertices of Peterson's graph so we can obtain exactly 2 crossings. So for example, I could move A and B inside, as well as E inside. So I'll draw the new Peterson graph down here. We'll keep C and D in the same place. But now, let's move F up above A. Well, we have the F is going to be connected to A. And let's put G in the middle of A, B, and E. So we have that there's an edge between F and G. Well, no, there's not. There's an edge between G and B. And let's move H outside next to B. So over here. Now we have that H is connected to F as well as C. So far we've avoided any crossings. And then let's move I outside to the left of E. We have that I is going to be connected to D and F as well as G. So D, F, and of course G. And now we see we've come across one crossing, which I'll label in green. And let's move J below G but above C and D. Well, we have that J is connected to E, G, and H. And now we have a second crossing here between JH and BC. And we have completed our graph, and we see that the graph only contains two crossings. So it follows that the Pearson graph has a crossing number of 2.